All right, so we are doing lesson 5 today. We are just about like halfway through the course. So if you have any questions, again, let me know, because halfway point, we're almost there. And yeah, so today we're doing recursion and searching methods, specifically more recursion though, since we're gonna learn about how to do that first before we go into searching methods, which is using recursion to help you. So kind of going to go over the base concept of recursion though. All right, so recursive method is essentially a method that calls itself repeatedly without having the user to type the method call many times over. So sometimes you want the method to do something that calculates on itself, right? Sometimes you don't want to write gigantic bunches of code. So I'm not sure if you guys know the factorial, right? Let me know if you know, but essentially if you're doing 6 factorial, right? That's essentially just saying 1 times 2 times 3 times 4 times 5 times 6. But you don't necessarily want the method to have to do that repeatedly, right? You don't want it to have just a for loop and then continuously do that. That can be a lot more lines of code, right? Usually, and sometimes you just don't want that. So what people do sometimes to shorten it is to just have a method that calls itself repeatedly. And there's it both shortens the amount of code you have to write and the time you have to take to write that. And I think it also makes it easier to debug later on. So that's kind of the pros of recursion. It does require a bit more thinking though, I do have to say, figuring out what has to go where, but it can be very useful. All right, so first an example. So I'm gonna kind of go through 2 examples mainly and then compare their outputs. So this should all look pretty familiar mostly. So first in the main method, we're saying print 5. So we're calling the method print, and we're saying the 5, which is an integer, should be the parameter there. All right. And then when we go inside of here, right, and we're looking at this, it's saying if n is equal to 0, then return. This is also called the base case, which is important to know. And I can explain a little bit more about it later on. But essentially this is saying if n is equal to 0, then just return the method, end it, and we're done. But then you see here that the next line is whoa, we're doing another method call, the same method. This is where recursion comes in. So we're saying print n minus 1. So what this does is we're essentially calling the print method again. But this time, instead of having n being 5, we're actually saying n minus 1. So essentially what this is doing is calling print 4, right? Because 5 minus 1 is 4. We're essentially calling print 4 with this line, and it's going back here again. So what happens in this case with recursion is that instead of just going on to this last print statement here, what happens is that it automatically calls the print 4 call here, right? Because again, Java goes sequentially. So it calls print 4, it goes back to this if statement right here, and is not equal to 0 still, so we skip that conditional statement. Then we reach the same call again, but it's the second time we're going through this. No matter what, it's still going to continue to call. So what happens is that it then calls print 3, right? Because 4 minus 1 is 3. I know it's hard to visualize, but bear with me. There's I drew a diagram, so that can maybe help visualize it a bit more. But essentially it's going to call print 3. It's going to go back here. It's going to print 3, right? And saying, okay, if n is equal to 0, it's not equal to 0 still. So we go back to here and we do the same thing again. We say print 2 now because we're decreasing the n by 1. We go back here and it's still not equal to 0. We go back to this print statement again. We're calling print 1 now. Going back here, it's not equal to 0 still. And then we're going back here and calling print 0. So now the interesting part happens. So now that n is 0, right? When we reach this conditional statement, it's saying if n is equal to 0, then return. Okay, well, n is equal to 0 now, right? So we return. So what happens is that we do not go through this again. We do not call the method again. We do not do print statement. What happens is that we end that particular method. This is like the very interesting part that like can get really confusing really fast. It's the fact that instead of just ending the method outright and then going back to the main method, what we're doing is after n is 0 and we return, we then go back to the other method calls that we did not finish. What that means is that we go back to n equals 1 because we didn't finish it, right? We still had that one print statement to run. So we go back to when print is print n equals 1. And then we finish the call because like we finished calling this method, right? We don't need to call it again. So we go out and print n. So you can see that the first output is n, sorry. The first output is 1, right? Because we're going back. Okay, well, after I print 1 out, then like I reach the end of this method, right? So technically that one's ended as well. Again, what happens is that instead of just ending the methods outright and then we just go back to the main method, it goes on to the other layers that we still have not finished. So the next one is n equals 2. So therefore, we finish the method call, we're going to the print statement, and we're printing out 2 because that's the end value there. Then again, we're going back to the other ones we didn't finish. So therefore, we're going back to n equals 3. Again, we finished the method call and we're printing out the end value, which is 3. We're going back to n equals 4. And so we're skipping the method call because we already did it. Print out n, which is 4. And lastly, the final thing that we were doing before, which is n equals 5, right? That was the original thing that we were doing. We end up skipping the method call because we already did it. And then we print out the end value, which is 5. So this would be the output, right? Because after we finish the n equals 5, right? We print out 5 and then we're done. That's when this method finally ends. And then we go back to the main method and do whatever else. So the output of this problem would be 1, 2, 3, 4, 5, like that. Does that kind of make sense? I know like there's no visuals on like exactly how it's working, but like, does it sort of make sense? Scale of 1 to 5. Okay, that is a good number. Well, for now, I guess. Trying to aim for higher, but it's fine. We're still learning, and it's a hard concept. All right, but yeah. So the thing to know with this, right, is that when we're going back through the other layers that we did not finish yet, what we're doing is we're going to the very next one that we just executed. Does that kind of make sense? So like, for example, when we got to n equals 0, right, the most recent one that we just executed, right, was n equals 1. So we go back that way. So we're kind of going like in reverse order now. And so that's an important thing to know when we're talking about the base case and how it's returning, and then we're going back through. So this is like a shorthand way of doing it, right? Because like you could write a for loop if you wanted to, but like, you know, I think this is a shorthand way of doing it and looks sophisticated. Yeah, I can definitely shorten the process for doing things, specifically for some other things, but it can be pretty useful. All right. Drawing. So I promised you guys a visual. This is my terrible handwriting. I apologize if you can't read it. But essentially what's happening here, right, is if you look at my cursor, where it is. So in the beginning, we're starting over here. We're saying n equals 5, because again, that's what we passed into the original method. This is kind of visual of what's happening inside of the method. But essentially what happened is that we go to the call method, right? We're saying print n minus 1. Okay, well then we're going to n equals 4. Again, you can see the arrows like it's going right here. We're going to the n equals 4 now. Again, because we're hitting the method call, we're going through the arrows to n equals 3 now. We're doing n minus 1 still. I'm following the arrow and going over here. We go to n equals 2. Again, we hit the method call, we follow the arrow and go over here. And n equals 1. And then we follow the arrow once more because of the method call and go to n equals 0. And then I write here that like, if n is equal to 0, then we return. This is where like we hit the base case and we just start going back. So after we hit that, we just automatically return because the condition is true. And therefore we're going back through the arrows, right? You can see the arrows going back to n equals 1 automatically. And we hit the system dot print. We're printing 1 because that is the n value for that particular method in that case. Okay. So like in that particular method call, n is still equal to 1. So that's why we're just printing out 1. Then we're following the arrows. We're printing out 2 because n is equal to 2. We're going back over to the arrows, hitting this particular print statement. We're printing 3 because n is equal to 3. Same thing for n equals to 4. We're following the arrows and we're printing 4. Lastly, we just go to the end and print out 5 because that's the end. Then we're automatically done, and that like finishes our cycle. So you can kind of see, like, it kind of looks like a circle, right? Like in a way, if you're following the arrows, it's a weird circle. I guess the better term for it would be a cycle. You can see that like we're hitting all of the important parts, right? Like we're going to all of the method calls, we're going to all of the print statements. It kind of flows through. And so hope that kind of made things a bit more clear. Like it's kind of a visual kind of thing. If you want to like draw arrows when you're doing these kinds of problems to better know how to do them, then that would be a good idea as well if you wanted to try that. But yeah, for sure, I think it's good to like keep track of what parameter values there are. All right, so there's another example and it looks pretty similar to the other one. The thing with this one now is that the main difference is that you can see that instead of this method call being over here now the print statement's in front of the method call. This seems like a very small difference, but it does generate a pretty decent, like, different output. So again, we're going to print 5. And then what happens is, again, and it's not equal to 0 still. So what happens is that it automatically goes to this print statement, right? And it prints 5 because, like, okay, it's saying print n, right? So we're going to print n. Then it hits the method call. And so then we call n is equal to 4 now. And it's still not equal to 0. Print out 4 because, again, that's the next thing in line. We call print 3 now. That is not equal to 0. We print out 3. We call print 2 now. And therefore, because of that, and it's still not equal to 0, and we print out the 2. Again, we're saying print n minus 1, so we're doing print 1 now. 1 is still not equal to 0. We print out 1, and then we call this print n minus 1 again. Now what happens is, again, is that we get to the same place that we were with the other one. So we call print 0. We hit the if n is equal to the 0 part, and because it is equal to 0, then we return. And again, very similar to the other one, we're going back through the layers, right? We're still going back to the layers that we just went through and going to see if we missed anything. So what happens then is that it's a bit different this time. It's because now that we finished the 0 case, right, we're saying if n is equal to 0, then we return. Then we go back into the n is equal to 1 layer, right? But then we see that after this method call, there's nothing else. So like, there's nothing else to do, right? So we automatically just end. Then we go back to n is equal to 2. Still, there's nothing left after the method call. So we skip that because there's nothing left. We go to n equals to 3, same deal, there's nothing left. N equals to 4, nothing left. N is equal to 5, and then there's still nothing left. So what happens then is that you're done. You're done with the method after you do that. And then you just go back to the main method and do whatever else is next. So therefore, the output for this one is just 5, 4, 3, 2, 1. So that's a bit of a different thing. And the important thing to know is that, like, the main difference is that we switched to ordering, right? Because the method call went later, we don't have to wait for later until we get whatever the output is, right? We don't have to wait to get to the print statement. So therefore, the output is different. So I think it's generally good to experiment with this to see, like, what's happening. Yeah, does that kind of make sense? Does like the difference between the two, how I explained it, does it kind of make sense? 1 to 5. Nice, I see the numbers increasing. That sounds good. All right, so like the other one, I had a drawing. Again, it's kind of not the best, but we'll see. So again, like we're passing in n equals 5. We're saying print the n value. So again, like it automatically prints now. So it prints out 5. Then we go to this particular method call here because it's sequential order. We're calling n equals 4. And then again, still it goes to the print statement at the top and it prints out 4. We're calling the method again. We're going to n equals 3. We're executing the print statement there and we're printing out 3. Then we're calling print 2 now. So we're going over here and then printing out 2. We're calling the other methods again, going to n equals 1, printing out 1. Then we call print n minus 1 again, and we get to n equals 0, where again, because of the fact that we already got to 0, then it returns. Then we start going back again. So you can see the arrows, if you follow it. We go back to here, but there's nothing left. So we go again to here. There's still nothing left. We go over here, still nothing left. Go to n equals 4, still nothing left. Then we reach n equals 5. Still nothing left, so we end. So yeah, again, that's like kind of a visual kind of thing. Hopefully following the arrows kind of makes more sense. So some general notes. Again, difference between outputs because we placed the recursion statement differently. And by recursion statement, I just mean, oops. By recursion statement, I just mean this method call right here, the one that's like continuously calling itself. We placed it differently, right? So that's the reason why there's a difference. So I think a good way to like think of it is like with each time that the method calls itself again, it creates another call of the method. So if you want to think of like layers stacked on top of each other, that's essentially a good way to think of it. So like we begin with the top layer, right? The bottom layer, sorry. And then when it calls itself, it stacks another same, like it's the same method, right? It's the same exact method, but we're stacking it on top of the original one. And then if we're calling itself more, then it's kind of like stacked on top of each other continuously until it's like a stack of pancakes, food references. So if it's like a stack of pancakes, then if we want to eat a pancake, which is like essentially like a metaphor for if you return, you have the base case and it just returns, then we have to go from the top to eat pancakes, right? Like usually. So we go from the top again. So that would be like one of the most recent pancakes that we just put at the top. Then we just continuously eat the pancakes and then we go back down again, right? So and then until we end up with the original bottom layer and then we just eat that and then we're done. I don't know if that made sense, but if you want to think of it as layers, I think it helps me to think of it. Just think of like as it calls itself, it's like stacking on top of each other. And when you get to the top, the only way to get back down again is to go back through the most recent ones and then go back down again. And again, it doesn't get to the print statement, instead just keeps calling until n is equal to 0. So this one's referring to the very first example, because remember that the method call was the first one before the print statement in the first example. So it didn't get to the print statement until after it started going back through the method calls. So it didn't get to the print statements and continue calling until n is 0. More notes. So this is kind of just like what I was saying before, but when it returns, then the program starts working backwards, going to every single call of the method and running it to completion before ending the code, which is again like why the numbers came out backwards than from what you would expect. Some more notes. In the second example, it already prints the numbers out on its way down to 0, right? Because we saw that the print statement was before the recursive call. So it was already like printing out the numbers, right? It was already printing out the numbers before we went to the other methods. So that's the reason why like it went out like that way, 5, 4, 3, 2, 1. So yeah, it means that when the method call returns, every layer would have already been executed, so nothing else would execute then. That's explained in the second example. If you use recursion as your return, then you won't continue on to any statements after you go back to it. So that's essentially just saying if you put the print n-1 part on a return statement, which you can do, then it's not gonna just, yeah, it's just not gonna continue on to any statements after you go back to it later on, because like return means that you're automatically just ending the statements, right? Like you're ending the method once you return. So like it wouldn't go back to any other statements later on when it returns to that print statement or that return statement. If that makes sense. All right, so I decided to like incorporate some images that I found online that I thought would probably be useful. It's kind of similar to what I had before with the arrow diagrams that I did myself. Only this time is the images are not mine, okay? I could not make these, so they are not mine. Be aware of that. So this is kind of just a factorial kind of example problem. I'm not going to go through it too deeply since it's kind of what we've been doing, but essentially you can see how like, okay, it starts off with n equals to 5. Then we're calling automatically. Yeah, sorry. I'm interpreting this wrong. It's just saying like if you did factorial n. And then what happens is that we're saying if n is less than 2. So that's kind of like the base case in this case, because like, okay, it's returning 1, right? Like we're ending the method then. But it's 5 is not less than 2, so we automatically go to the else statement, and we return 5 times the factorial 4. So that's essentially like the n-1 part. But you can see that now like we're trying to return a value that the recursion can help us calculate. So again, if you know about factorial, that's like the 6 times 5 times 4 times 3 times 2 times 1 thing. If you had 6 factorial. This becomes a bit easier to do now because like, you know, there's a rule. Yeah, this is kind of like how you would try to calculate it, because then you would say like 5 times factorial 4. Okay, well, we need to call this again to generate the other values. So we follow the arrow and go over here to factorial 4. And again, it's the same method. It's just we're using different numbers now. So we're saying 4 times factorial 3. Going over here. Again, I'm calling factorial 2. Go over here. And factorial 1, and we go over here. But now because it's less than 2 now, because it's factorial 1, right? So we just return 1. We go back to here. So the thing with this now is because we returned 1 as a result of this final method, right? Returning 1. That means when we're saying factorial 1 now, if we go back to here, well, we know that factorial 1 is 1, right? Because it returned 1 when it ran this particular method. So what happens in Java, like internally, is that this factorial 1 is replaced by 1, right? Because that was what we calculated in a later method. If this is replaced by 1 times 2, which is 2, and then we're returning that again. So what happens is that this 2 is then sent back up to the other method over here. And again, we already know what factorial 2 is because we already calculated it here, right? So this factorial 2 is replaced by the 2. And then we multiply by 3, which gets us 6. Again, we're turning the 6 back up to the other method over here. Again, we know that factorial 3 is 6, so we replace that factorial 3 with the 6. 6 times 4 is 24. We return that number back up. Replace the factorial 4 with the 24, and then finally calculate what 5 times 24 is, which I don't know off the top of my head. But essentially, like, you can see how like it's a complicated process, but it gets like, it's really nice sometimes to just see that kind of logic working through. But yeah, this would call recursively, and this is an example of like how you can calculate specific values. All right, that is one example. This is kind of more of a general approach. So I haven't really talked about this before, but iterative approach is kind of like what we did before with loops, right? Usually with loops, we would say, okay, if we're going through an array, we would go from the first element to the last element, and we would just go one by one through that array, right? But the thing with this now is that, let's say we're saying make a pile of boxes to look through. Usually we would say like, well, the box isn't empty. So like if we had a while loop, then we would say, okay, grab a box or like do something. If you find a box, then add it to the pile of boxes. So like that would be like the conditional statements, right? That we would put. We would say, okay, if you find a box, then do this. If you find a key, then do something else. This is kind of like what we do. Usually we have a while loop or some kind of loop. We have an action, and then we have conditional statements depending on, that will do different things depending on what happens. This is saying like, okay, if this happens, then go back to the pile, which goes back to the loop again. So this is kind of like the regular loop kind. On the other hand, with the recursive approach, what happens is that, okay, we go through every item in the box, but then we automatically say, okay, if you find a box, then you go back. If you find a key, then you're done. So what happens is that like you look at this, right, and it looks, the recursive approach is a lot simpler and a lot more down, right? There's not as much actions with it. So kind of something you want to think about. Yeah, it still does the same function, like it still does the same thing. And it also still has the loop part. It's just a lot simpler. So yeah, this is kind of what the recursive rule is. So like the print n-1. This is essentially the if you find a box part. Otherwise, like the base case is this part right here. If you find a key, you're done. That's essentially where like, okay, we found something, or like a condition is met, then we return because we're done. So that's kind of what it is. Again, the image is not mine. And kind of lastly, this is another recursive method in Java. And you can see here that, again, we have the base case here. If something is true, then we return an end. Or else we were just doing the base case, like the recursive rule again. But this time, like it's a bit more complicated in the fact that like there's two now. There's two different method calls. It looks scary, but if we go here, right, we're saying mystery 4. It's gonna call mystery of 3 because like 4 minus 1 is 3, right? And we're calling mystery 3. We're calling mystery 1 because that's the n-3 part. And then we essentially do m3 first for this one because again we're like minusing 1 and calculating one of those. So m2. Mystery n-3, which is 0. We go to m2 and we're saying m1 and the -1 because again we're minusing 1 and then minusing 3. Go to m1, same thing again, you're doing that same call. But then we see that like m0, it's not really working, right? Because like you go into m0 and then what happens is that we have to calculate m-1 and m-3. But then we can see that it doesn't fulfill this condition, right? So we're returning 2 for both of those values because they're both negative. That means m0 is equal to 4 now because m-1 and m-3 are both 2, which means 2 plus 2 is 4. And then m-2, that is also negative, so it returns a 2 here. And again, you can see like how we're just going back through, like we now know these values, so we substitute them for the original method calls. This m0 is now 4, the -2 is now 2, and we're just continuously going back up until we find the original value. So yeah, this is another kind of thing you can do. Again, like it's complicated, but it can really shorten your code because like otherwise, how are we supposed to do this, right? I don't know, right? If you didn't have recursion, then it can take a lot of code, right? Because then you wouldn't be able to store these values, right? Otherwise, you would just need to store them in an array but then an array can't expand. But then even so, if you had an array list, then like it's a hassle to have to find it out. So that's kind of a thing that's important with recursion. Again, the image is not mine. Right, but generally in recursion, it's required that you have a base case, or else you might end up with an infinite recursion method. So if you never had a condition that will make it so that the method will return at some point, then it's just going to continue going on and on, right? You can continue doing print n minus 1 on and on if you did not have that base case of saying if n is equal to 0, then we return. So it's important to have a base case like that, like having a condition for if this condition is true, then we return. And also make sure that you have the recursive rule that you have set will end up at the base case, or else defeats the purpose of a base case. So let's say that we said, okay, well, if I don't know. But the point is that like if you're saying, okay, let's say that we're saying print n minus 1, right? But then we're saying if n is greater than 5, then we will return. But the thing is, you can say print 3, right? And it's going to continue going downwards. Like it's going to continue calling print n minus 1 continuously downwards. And it's never going to reach that base case of n being greater than 5 because it's always going downwards. I'm sorry, there's no visual for that, but that's kind of the basis of it. So you have to make sure that the recursive rule that you have will end up at the base case at some point. Because otherwise, like it's never going to reach a base case, which still gives you an infinite recursion. And that is it. Okay. Coolio.